Welcome back to the Minecraft tutorial. This is going to be part 3. In this part we're going to be going over making the surface and implementing or making a very basic implementation of the noise plugin that I had you install in part 1. To do so we're going to be making some of the assets I'll be using later. They just won't be in their final version just yet. So let's get straight into it. The first thing we want to do is we are going to want to get that plugin set up. So let's start off by actually adding the plugin. So to add the plugin, you want to go into Edit and Plugins. Now, go into the installed ones, and in installed you have Faster Noise Generator. If you have other plugins, they'll appear as well. Obviously, you might not have the same as me, but this is the one we're using here. So check that and then do Restart Now. I'll join you once my project is restarted. Now that we have set up our plugin, we're not actually going to do it just yet. First, I want to get our instant static meshes set up, because last time we did it through our temporary testing actor here. Now we're going to make the ones that's going to be used for the rest of the project. And they're going to be, we're going to open blueprint class, and we're going to look for instanced static mesh. So right here, there we go. We don't want the static mesh, we want the instance static mesh. Open that and call it ISM for instance static mesh and block. We're going to have another one which is going to be the child of this, and it's going to be for foliage, so we can do that as well. Right click, create child blueprint, and ISM foliage. Now let's start with the block as it is the parent. So for the block we're going to need two things. We don't need our event tick. We're going to need a basic variable for the data asset, because that's the kind of key element we need. We need to know what data asset are we creating. So data asset right here, and it's going to be of type DA underscore base, because we need to be able to reference a foliage and a block as well. So select that here. What we want to do with this information, what we want to do with this data asset, is we want to load it, because alone the soft reference can't be used. We want to do load async asset right here, and on completed, as this will be executed only after it's called, but we want to have it once it's completed, we want to call a cast, because we want to know what object type this is, because this is currently just an object. We want it to be a DA base, so we want to cast to DA base. Go. Not there, I want it on completed, so make sure it's on completed. And with this, we then want to create a new function. Now, what we want to do is we want to get our material parameters set up here. But to do that, we need to be able to have it as a function, because we need to do it differently for the foliage as we do for the normal block. So to do that, we'll add a reroute. And to add a reroute, I found this trick out recently. If you just press R while dragging a node, you can add a reroute. Now, with our reroute selected, we can right click and say collapse the function, and this function we will simply call set material, or setup material, because set material already exists. Now there we go, plug it in here. And what setup material is going to do is it is going to cast to our DA block here, because we need to know what it is. We need to know the information from that block specifically. So we're going to cast to DA block, or blocks, sorry. And we want to actually save this variable for now. And what we'll call it is we will promote it to a variable, sorry. We'll call it loaded block. Plug it in here. And from loaded block, we want to do two things. First, we want to get our foliage, our transparent, because we want to be able to select between which base material we are going to use. So for that, we want to say select, and we'll choose at the bottom here this select, so that it's a wildcard, so that once you plug it in, it will adapt to what we need. What we want to call is we want to call create dynamic material instance. And what we plug in is, well, this right here, the source material. Now by default, target is self. The reason we can use self as a target here is because this actor we're working on, or not an actor, component we're working on, is a child of the static mesh, meaning that self is a valid actor to the function directly. As if we can do this, we can check this by looking at class default. We actually have a static mesh here. So, and while we're at it, while we're here, we actually want to set this up to be our cube. So now by default, it will be the cube. And for the material, we can compile, but we're going to be setting it right now by taking this material and saying set material, which will do it for this component itself. Now, before actually doing this, we need to take this material and actually update the material instance. And to do that, we want to get our loaded block and say parameter, set material parameters, and we'll put this in here. And with that, with our material in now, we actually have an updated version of that material being plugged into here. Now, the last thing we just need to do is with our is transparent here, what material do we want to choose? So if it's false, meaning it's not a transparent material, we just want to use mi block right here. If it's true, we want to use the transparent one. So just because there's a few of the same name, I'm just going to go and get it directly from the actual material. So right here, m transparent, there we go. And with that, we're done with setting up our ISM block, at least for now. Once we start doing placing blocks and breaking blocks, we'll actually have some more stuff to add here, but for now this is enough. So with this, we now want to go and modify quickly our other one, so our foliage. And so to do that, we just want to double click, and by default we do need the parent one here, but because we made our foliage before writing the parent or finishing the parent, it isn't visible. So to add the actual parent event begin play, we need to right click on begin play and say add call to parent function. And that's pretty much all we need to do here. We just need to now update the override one. So our setup material, we need to make it so it's adapted to the foliage. So let's do that. So in our functions, click on override, go to setup material, click, and we can get rid of the parent because we don't want to use the parent. We want to do it ourselves. So for that, what we can do though, is we can go and actually copy most of what we do in setup material. We can copy this right here, and we'll just need to cast it differently. So here, we will say cast to DA foliage. And once again, for some reason, it's not appearing. I don't know why. DA. So I'm not sure why it's doing that. Let's just go and go to data assets, open foliage up, compile it. And I think that makes it reappear. Yeah, so I don't know why it does that, but just open it up, compile and save, and it should reappear correctly in the research tab. This time we want to take this and simply plug it directly into the target here. We don't want loaded block because this is an actual block, it's foliage, so we don't want to treat it the same way. But the rest obviously stays the same. We don't need to change the logic here because it's the same thing. The only thing we do need to change is the source material. With this time we'll put m foliage. So this one right here. And one last thing also before I forget, in class defaults, we also need to change the actual static mesh, otherwise it doesn't work. So cube needs to be changed to imp foliage. Compile and save, and that will do it for our 2 instance static mesh. Now, currently instance static meshes alone do nothing. So we need to set up how we can actually spawn them. So how I decided to handle this, obviously there's many ways you can do this. I decided to do it with an actor called a chunk, which is just going to be the actor that handles everything within one chunk. So to do that, we need to make that actor. So in our blueprints, right click, blueprint class, actor, a underscore chunk. There we go. To make it more scalable, we're going to make a function so that we can always create a new instance static mesh as easily as possible. And so we're going to call that function make instance or instanced static mesh. There we go. And it's going to take an input of type DA base, as it needs to know what type of data asset to use. And obviously, once again, using a soft object reference because we don't want to load it unless it's necessary. And in this case, it isn't. So we'll call this input. Now, the way we're going to do this is we're going to use a branch, and we're going to actually check if in this chunk, if we already have a instance handling this specific data asset. Because if we already have, let's say, a sand component, we don't want to add a second sand component, we just want to add an instance to that component. So to do that, we need to actually store in memory which input or which data asset is already being used. So to do that, we want to promote this to a variable. And we're going to call this instance map. And we're obviously going to turn it into a map and not have it be just a simple set. So select it, and in details, put it to a map. And in the map, we're going to use ISM block, which we made earlier, and this time it can be a hard reference. And the reason we can do that is because Foliage is a child of block, so it'll work no matter which one we choose with the DA base. And so with this, we can now go and find our input. And if our input does exist, meaning we do indeed already have one, then we just want to say that we're going to add to this instance. So in that case, we're going to add a return node if it is found and say return that output, and that output will be used. On the other hand, if we don't, we need to add it. So in that case, we need to say add instance or ISM, sorry, and we want to say add ISM block. Now, by default, we don't need to change the relative transform or anything like that because it is going to be attached in 00 to this actor, and it's the instances that we add that will actually be moving around. So one last thing I did forget though, right here we do need to expose this data asset on Spawn. So we need to go and reopen the block here for a second and select our data asset, put it instance editable and exposed on Spawn. Compile and close it. And it's still not visible here, so we just right click and say refresh. There we go. And so now we want to put input in here. And now because we've now added our instance static mesh, we now need to tell our map that we do have that, so that next time we don't have to recreate it. So we say add, we add our input, and then we just add our actual return node here, which is the new instance static mesh. Now obviously we'd still need to handle or do what we wanted to do with it, so we add a return and we plug this return value right here. There we go. Compile, save. And just to finish things up, we just need to make a duplicate of this for the foliage. So just duplicate the top one, rename it to make instanced foliage. And all we have to do is we want to get rid of this and say add ISM foliage instead. Plug in the data assets, plug that into there, and that into the add, and we're done. That does the foliage as well. Now we can compile and close. And just to test if this is working, what we can do is we will say, close that. We'll say we want to add an instance static mesh, and we will say, okay, let's add one right here, and we can leave this null. I'm going to leave it null so you see what it looks like. We're going to say, by default, you are going to be add instance, and here is where we actually put the transform of the size we want, and we're going to say 16 by 16, which is the size of a chunk. So we compile, and currently there's none in the map, so won't do anything, but let's just add one so we can see what happens when we play. So if we play, we now have a 16 by 16 block right here. Now, once again, that's because we have no inputs, so it just makes kind of the gray default texture of Unreal. If we say grass block, compile and save, we will have grass, like this. Now, for the foliage, we can't do it with this, so we need to actually try to use this one. But in the case of foliage, we want to usually keep it to 1 by 1 instances on scale, because it's not meant to handle being multiplied in scale. It doesn't actually make extra instances, so this wouldn't really work. So we'll just ignore that case for now. Today we're just going to be focusing on making the terrain, not the actual bushes and stuff like that. So with this, we now actually have terrain. We have a flat terrain. We can make that as big as we want. So let's move on to actually doing that. So next we need some common spot where we get to decide the general rules of the map. So for that, what I chose to do is we're going to use the game mode. So we're going to go into blueprint classes again, and we're going to select game mode base, and we'll call this GM Minecraft. Now, by default, this isn't actually going to be used. We need to actually set that up. So open up world settings. For those who don't have this collapsed like me, I'm not exactly sure, I think it was in the most recent update. We can pin it just so it's always on the side. We want to select our game mode overrides and put our GM Minecraft. Now by default, if we play now, we actually get the spectator camera, which is not what we want. We want the first person camera to stay. So we want to open this right here. And we want to change two things. First, we want the player controller class to go to first person. But we also want to change the default pawn class here back to first person as well. This is all in the class defaults, which you can get by selecting this or by selecting up here. So now if we play again, we can move around just fine. There we go. The first thing we can do here to show kind of the idea of how the chunk will work, we're going to get rid of this chunk. We're going to get rid of all the other actors around here that we have placed since the first part. And we are going to spawn a few chunks. So we're going to do a double for loop here for X and Y pretty much. So we're going to plug this in, line these up. We'll just reroute this and we're going to say -2 by 2, -2 to 2, and the same on the other one, that way it's just square. And we want to say to float, and we'll just copy this because we want it twice. There we go. So let's just line these up. Now, what we want to do is we want to add actor from, or no, spawn actor from class. The class we're going to choose is obviously our chunk, what we just made. So search for chunk, a chunk right here. Spawn transform now we actually need to take into account because we can't just leave it at 0, 0 because that's where it needs to be at the specific coordinates of that new chunk. Now one thing to take into account is every cube we make in the game is 100 by 100. So that means every chunk can't just be 16 by 16, it needs to be 1600 by 1600. So we need to take that into account when we're actually placing here. We need to actually multiply this value by 1600. So we're going to make a vector here for X and Y, plug this in, and we are going to multiply the total by 1600. So float and plug this in to the transform. So now if we play, if everything worked correctly, we have a big terrain for this, well, the play area, I guess you could say the map. And so if we look, we have -2, -1, 0, 1, and 2. And the same on the Y and the X. So we achieved our goal. But this is kind of flat, right? It's like the original creative world where you just have 3 layers, nothing. We want to actually give it some height. So now is actually where the noise comes in. Finally, after 3 parts, we're on the noise. So for the noise, we need to transfer the information from here because we don't want to have every chunk having a different noise. That's a waste. We just want to use the same noise everywhere. So we're going to do that. And we're going to do that inside of our game mode. So we're going to detach this for a second. We will be using it. But what we want to do is right here, we want a sequence just so we have it more readable. Second part of the sequence is we are going to make our chunk. On the first part, we're going to make our noise now. So to make our noise, we want to look for the construct object. So place that right here. So what we want to make is we want to make our noise object. And so the noise object is called fast noise wrapper. So select that. And what we want to do is we want to save this because we want to transfer this information over. So we need to save it as a variable. So we want to promote this to a variable. We'll call this variable surface noise for now. We'll be making a few of them because for each different type of surface, we need a different type of noise. So with this noise, what we want to do is we want to then say set up fast noise. And this is where we actually get to change the settings that apply how it's going to look, the kind of terrain layout, let's say. So the main thing we want to look at is the seed, and the seed is going to be kind of what it looks like every time. The seed will allow us, just like in Minecraft, if you put in the same seed, you will get the same map. It doesn't matter what computer you're on, who's playing, who it is, it will always be the same map. Without any modifications, obviously, because the seed only does the basic generation. So to make a very basic one, we're going to try and recreate a desert. So I'm just going to be taking the values that I already have, because for me they work just fine, so we'll just stick with those. If you want to play around these values, that's fine. On the actual marketplace where you got this plugin, there is a link to the documentation if you want to read through it, which is also actually has a link to the other documentation on GitHub, which is even more detailed if you want to read more on it. So for us though, we're just going to stick to making something rather simple. We'll change the noise type to Perlin. We're going to change the frequency to 0.02, sorry. And that's all. That's all we're going to do. This is going to make a very plain looking desert, at least in layout. So with this, we are done. That's all we had to do. That's all we have to do for this noise. Now we just need to tell it how the chunk is going to handle it. So for the chunk to handle it, we need to do something different here, because this just makes one basic flat point, which we don't need. So we can get rid of that, or at least this we will still need. So what we're going to do first, we're going to need another sequence. The first thing we need to do is we need to get a reference to the game mode so that we can get a reference to our noise. So to do that, we want to get game mode, and we want to cast this to GM Minecraft. Now with this, we then get to save this as a variable so we can reference it later very easily. So we'll just save it like that, as GM Minecraft is just as good as any other name. So now what we want is we can actually go back to our here, and we'll actually just copy this for now. And we're going to plug this in right here. And what we'll do here, and obviously we can't do -2, here we need to do 0 to 15. 0 being the coordinate at the bottom left, and 15 being top right. So 0 to 15 again. And the reason we don't do 1 to 16 is because by default, we do want a block to be in 0, 0, with 0 as coordinates. So we do 0 to 15 because it's still 16 in count. So what we're going to do is we'll use this function that we made here so that we can create our grass block or find the instance that we need to use that grass block. So what we do is we then want to say add instance like before. Now we're keeping this simple because later we'll be doing kind of greedy meshing where we will say, well, if the block to the left of it is the same, we can stretch it. But for now, we're just going to do 1 by 1 in scale just to make it simple so you can see how the noise is applied. So right here, we're going to get this, we're going to reroute it, and here it is 0, 0 or 1, 1 all the way to 16. So we need to actually change this so that in scale wise it is the right size. So instead of doing times, I believe 1600 that we did here, we just need to do times 100. So multiply, and we'll put float and 100. So right now, if we do this, we should have the same result visually as before. There should be no difference. There we go. So we have the exact same result, no difference. But this time, each block is an individual block. It's not stretched. It's just one block, or one instance, more like. Now we want to actually go and add the height. So the first thing we'll do is we will actually call add right here. That way we have it easy to read. And we'll just actually make this make vector. That way this gets a bit smaller and more easy to handle. There we go. Now, for the height, what we want to do is we want to get our noise. So from our AsGen Minecraft, we want to get our noise surface. And to transfer this into an actual value for noise, what we want to do is we want to get 2D noise. And with 2D noise, we want to simply plug in X and Y. And this will be our Z. Now, let's go and compile. And there is no difference. Now, the reason there's no difference, it's not a mistake, it's just how it works, is because we're talking about a noise image, a noise texture, whatever you want to call it. And in any case of a noise texture, we're talking about white and black values, meaning it is 0 to 1. So here, there is a difference, it's just so small that we can't see it. So to make that more visible, what we can do is simply say times 1000. And now we will actually see a difference. So if we go and play, right here, we can now finally see we have the noise applying. But there's still one issue. Right now, the noise is repeating. Every single one of these, it is repeating. And the reason for that is because we are doing it by saying, well, 0, 0 should have this noise. We check for the noise and we say, oh, well, 0, 0 is the same. But the thing is, we're doing that for every single one. This is 0 to 16, this is 0 to 16, this is 0 to 16, but that's not correct. If this is 0 to 16, then this should be 16 to 32, and so on. So to do that, we need to actually make a slight modification to our chunk. We need to know where our chunk is located. So to do that, we already have our for loop here, which knows where it's located. We just need to tell it where it's located. So to do that, we need a new variable, which is going to be of type, well, we'll call it chunk coordinates. And it's going to be a vector, very basic vector, but we want it to be exposed on spawn. So compile. And right here, we go back to our GM Minecraft, right click on a chunk, say refresh because we just compiled. And we simply want to plug in our vector here, right into it like this. And the reason we can just do that is because this is coordinates. These are coordinates and this is world space. Later, we'll probably set up some macros and stuff to handle this because we're going to be going a lot between world space and just blocks. Just to make it easier, we'll do that in another part, not this one. So with that, we now need to tell it to take this into account for the noise. Because right now we need to have this and this added together so we get the noise correctly. So to do that, first, we need to multiply this by 16. Because we need to know where it is in the world, or at least where it is block-wise, because we don't want to use world locations for the noise because there is no point. Otherwise, we'd be looking at spot 100, spot 100, spot 200, spot 300, which would kind of not actually get the noise. It would just get a different kind of random thing, and it wouldn't be as smooth as the Perlin noise we chose. So turn this to a float, put it to 16, and then we want to say add, and what we want to add is a split vector, which is just going to take in x and y. So make sure you choose the 4 here. And we need to split it again because by default we can't actually modify that. So now if we go and compile and save and run it again, we get a proper noise here. It actually goes and curves correctly. And it's not just doing like a repeat every chunk. Right here we have different chunks that have different appearances because they have different scales. But this isn't Minecraft, right? This is just, it's just a smoothed out version of a noise with just blocks, but the blocks aren't 100 units apart. So to do that, very simple. We take our result here, we give it a bit of space, and we simply say snap to grid, not that one, snap to grid float. And in our case, we're going to say 100 because that's the size of our block. But if you want something else, if you want something maybe 50 or maybe more smooth or less smooth, then you can change that. And so right here, if we compile, we now have a perfectly good looking Minecraft map. Now, obviously this is just the surface, but the surface is complete. Right here, we could change it out for a desert and it would look a lot better, but just for the testing sake here, we got the result we wanted. So I hope you enjoyed this part. In the next part, we are going to be going over breaking these blocks. And in the part after that, we will be doing placing. And once that's out of the way, we'll finally start building on the caves and the actual more advanced systems. I hope you enjoyed, and I will see you in the next part. Goodbye.